Hello, Matt G4IYT here. Today we're looking at the full license mock examination number 1, version 1.6. We've reached question 57, which reads, the dBm is often used to express power with respect to 1 milliwatt. That is 0 dBm equals 1 milliwatt. What power is 20 dBm? So this one has nice easy numbers, and the shortcut I like to follow with decibels is for every 10 dB. For every 10 dB, we multiply by 10, and for every 3 dB, you multiply by 2. And we've got 20 dBm here, so that's 2 lots of 10 dB. So we take our 1 milliwatt and we multiply it by 10, and then we multiply it by 10 again. So 1 times 10 times 10 will give us 100 milliwatts. So a slightly longer way of working this one out is to use the formula, although for this particular question we're not given the exact formula that we need in the EX309, but we can kind of work our way back to it from this one, which is gain or loss is equal to 10 log to the base 10 times a ratio, and that gives us a value in decibels, and the ratio here is P out divided by P in, and that gives us decibels. That will give us decibels gain of an amplifier, or decibels loss of a bit of coax or an attenuator or something. And the ratio here is relative to P in, so if P out, so it might be 200 watts and P in is 100 watts, that's going to give us a number. That's going to give us a number above 1 for this ratio, and so multiply that by 10 log to the base 10, that's going to give us a positive number of decibels. Similarly, if P in is 100 watts but P out is 50 watts, that's going to give us a number that is less than 1, so 50 divided by 100 will give us 0.5 times 10 log to the base 10, that's going to give us a negative number of decibels. So this equation is related to dBm because if we're calculating the gain or loss of something, our reference value is P in, and our decibels are relative to P in. And with dBm, we know that all our power values, our dBm value is relative to a value of 1 milliwatt, right? 1 milliwatt here, and our P out is basically the power that we want to express in dBm. Of course, this is going from that absolute value to the dBm value, and we actually want to go the other way around. So we have to reverse this equation, and we want to do the inverse of log 10, which is 10 to the power of something, which would be our dBm. And then we also want to divide that by 10 because we've got this multiplied by 10 here. So if we do 10 to the power of our dBms over 10, we should get our absolute value out. So coming back to our question, we want to do 10 raised to the power of 20 over 10. Well, 20 over 10 is going to give us 2. If we plug that into our calculator, we do 10 raised to the power of 2. That gives us 100, and that gives our value in milliwatts, so our answer is going to be 100 milliwatts. Let's skip down to the answers, see if we've got that right, and we can see that for question 57, it is of course option B, or 100 milliwatts. Thank you very much, I'll catch you for the next one.